What's up, everybody? It's Chris, and I'm back with another Chem 1B video. Today we'll be going over reaction rates, and we're going to go through 3 examples together. So example problem 1 and 2 reads, consider the following chemical reaction to answer the following problems. So we have 2Al plus 6HCl goes to 2AlCl3 plus 3H2. Now, you can get a question asking you to determine the rate of formation or a question that asks you to determine the rate of consumption. So we're going to do one of each for now. So if it ever says what is the rate of formation, we have a template that we can follow. So we're going to use the change in concentration of whatever we're talking about. So in this case, it's H2. And we're going to put that over a change in time. Now, anything that's on the right side is being formed. So it's going to have a positive rate of formation. And anything on the left is being used up. So it's going to have a negative rate of formation. So because H2 is on the right, we have a positive rate of formation. And what we're going to do is we're going to take the coefficient that is attached to that compound. So in this case, H2 has a 3 next to it. And we're going to put the 3 on the bottom. So in this case, our rate of formation is 1/3 change in concentration of H2 over change in concentration of, or change in time, sorry. Now, what if I ask you about the rate of consumption of Al? Now, we're again going to do the change in the concentration of what we're talking about. We're going to put that over change in time. Now, in this case, because aluminum is used up, we have to actually throw a negative on it. So now that we have this negative sign, and then we also still have to factor in that coefficient. So here again, we have a 2 right next to it, so we have 2 on the bottom. So this one is actually -1/2 change in concentration of aluminum over change in time. Okay. Now there's also a third way you can get a reaction rate question. And it could read, how is the rate of formation of AlCl3 related to the consumption of HCl? So if they ever ask you to relate two reaction rates, what you just have to do is set them equal to each other. So what this really translates to is set the rate of AlCl3 equal to the rate of HCl. You do them independently and then set them equal to each other, and the answer could be formed in a couple of different ways. So let's just do that first, right? So again, we're going to have the change in concentration of, again, we're talking about AlCl3 here, over change in time. And then we're just going to find whether it's on the right or left. So AlCl3 is on the right side. So it's going to be positive. We don't have to worry about a negative sign, but there is a 2 next to it, so we have to throw a 2 down here. Cool. Now, what about the rate of HCl? So we have, again, the change in concentration of HCl over change in time. Now, in this case, HCl is on the left, so we have to throw the negative sign, and we actually have 6 as the coefficient, so we throw the 6 on the bottom. And this would suffice as a correct answer. However, typically what you'll find in an answer, if it's multiple choice, is that they take this coefficient here and they multiply it into both sides. So just for the sake of popular answer choice identification, we're going to multiply both sides by 2. This is now canceled. So you would get change in AlCl3 over change in time equal to -2 times the change in HCl over 6 change in time. And then again, we could always just change this to -1/3 just by simplifying the fraction. So -1/3. All right, cool. So if you find yourself struggling with reaction rates, feel free to drop into SI office hours or comment down below. Thank you.